Reversible hash function? I need a reversible hash function. Obviously the input will be much smaller in size than the output, that maps the input to the output in a random looking way. Basically, I want a way to transform a number like 123 to a larger number like 9,874,362,483,910,978, but not in a way that will preserve comparisons, so it must not be always true that, if x1 is greater than x2, fx1 is greater than fx2, but neither must it be always false. The use case for this is that I need to find a way to transform small numbers into larger, random-looking ones. They don't actually need to be random, in fact, they need to be deterministic, so the same input always maps to the same output, but they do need to look random, at least when base 64 encoded into strings, so shifting by z bits won't work as similar numbers will have similar MSBs. Also, easy, fast, calculation and reversal is A+, but not required. I don't know if I'm being clear, or if such an algorithm exists, but I'd appreciate any and all help.
None of the answers provided seemed particularly useful, given the question. I had the same problem, needing a simple, reversible hash for not security purposes, and decided to go with bit relocation. It's simple, it's fast, and it doesn't require knowing anything about Boolean maths or propos algorithms or anything else that requires actual thinking. The simplest would probably be to just move half the bits left, and the other half right. This is reversible, in that hash n equals n, and has non-sequential pairs, n, m, n is lower than m, where hash m is lower than hash n. And to get a much less sequential looking implementation, you might also want to consider an interlace reordering from MSB, Z, A, LSB, to MSB, LSB, Z, A, or LSB, MSB, A, Z, or any other relocation you feel gives an appropriately non-sequential sequence for the numbers you deal with, or even add a XOR on top for peak desequentialing. The above function is safe for numbers that fit in 32 bits. Larger numbers are guaranteed to cause collisions and would need some more bit mask coverage to prevent problems. That said, 32 bits is usually enough for any non-security UID. Also have a look at the multiplicative inverse answer given by Andy Hayden, below.
Another simple solution is to use multiplicative inverses, see Erie Clippert's blog. We showed how you can take any two coprime positive integers x and m and compute a third positive integer y with the property that, xy, %m equals 1, and therefore that, xzy, %m equals z%m for any positive integer z. That is, there always exists a multiplicative inverse, that undoes the results of multiplying by x modulo m. We take a large number, for example 4 billion, and a large coprime number, for example 387,420,489. We first calculate the multiplicative inverse with modinv, which turns out to be 3,513,180,409. Now, we can define the inverse. Note, this answer is fast to compute and works for numbers up to 4 billion, if you need to handle larger numbers choose a sufficiently large number, and another coprime. You may want to do this with hexadecimal, to pack the int. If you choose a relatively large coprime, then this will seem random, be non-sequential and also be quick to calculate.
What you are asking for is encryption. A block cipher in its basic mode of operation, it reversibly maps an input block onto an output block of the same size. The input and output blocks can be interpreted as numbers. For example, ICE is a 128-bit block cipher, so it maps an input 128-bit number onto an output 128-bit number. If 128 bits is good enough for your purposes, then you can simply pad your input number out to 128 bits, transform that single block with ICE, then format the output as a 128-bit number. If 128 bits is too large, you could use a 64-bit block cipher, like 3-Day, Idea or Blowfish. ICD mode is considered weak, but its weakness is the constraint that you have postulated as a requirement, namely, that the mapping be deterministic. This is a weakness, because once an attacker has observed that 123 maps to 9,874,362,483,910,978, from then on whenever she sees the latter number, she knows the plaintext was 123. An attacker can perform frequency analysis and or build up a dictionary of known plaintext/ciphertext pairs.
Basically, you are looking for two-way encryption, and one that probably uses a salt. You have a number of choices. Triples, ICE. Here is an example: simple insecure two-way obfuscation for C#. What language are you looking at? If net, then look at the encryption namespace for some ideas.
Why not just XOR with a nice long number? Easy. Fast. Reversible. Or, if this doesn't need to be terribly secure, you could convert from base 10 to some smaller base, like base 8 or base 4, depending on how long you want the numbers to be.